Here's a summary of nociceptive pain, and I think we should start with endpoint. Why is it? What is it? What is the result of detecting tissue damage? Well, one is we're going to get out of the way. That's a spinal cord reflex. If you touch something hot, then fairly quickly you're going to move your hand. That withdrawal occurs because nociceptors talking to the spinal cord, and the spinal cord is talking back out to muscles, and you get withdrawal. The other thing you're going to do is you're going to avoid those things that in the past have produced pain. That a stimulus, tissue damage, maybe grabbing onto a hot stove, you're not going to do that more than once. So that means information has to make it well past the spinal cord and into the cerebral cortex, because the perception of pain from a stimulus that is noxious doesn't occur in spinal cord, doesn't occur below cerebral cortex, it occurs in cerebral cortex. So our emotional reaction to painful stimuli from something that's caused tissue damage or inflammatory pain, any of that, well, that has to reach cerebral cortex in order for it to occur. Okay, so that's the back end of things. Front end of things is over here. And what we have here is another division of labor, another example of parallel processing. Because even though the figure makes it look like a single nociceptor, so this one nociceptor here, has all these receptors in it, it just is not true. Not true at all. It may have more than one, but it's not going to have all of these. You have fundamentally distinct types of protein complexes in the plasma membrane of nociceptors that allows you to detect thermal energy. We've talked about TRPV1, opens at 42 degrees centigrade. I'm going to tell you TRPV2 opens at 50 degrees centigrade. So the hotter something is, the more channels open, the more the axon, the dorsal ganglion cell, the nociceptor responds. Acids, yep, there are separate receptors called A6 that respond to acids that are not part of TRPV1, acid sensing ion channels. That's what A6 stands for, ion channel. I'm going to tell you about one right now. So there's an ASIC that's present in the pericardium. That is the lining around the heart. And it is depolarized, pericardium, it is depolarized by the presence of protons because it has A6 in it. The A6 react to the protons, depolarize the afferent, cause it to fire, particularly if the acid, the source of the protons, is a buildup, is lactic acid. And when does lactic acid occur? That's what happens when muscle is deprived of oxygen. So when cardiac muscle is deprived of oxygen, lactic acid builds up really quickly. A6 detect it. They open, generate action potentials, and nociceptors report that the cardiac muscle is now being deprived of oxygen. That, by definition, is a heart attack. So the pain of a heart attack is because of nociceptors that stick in their membranes, a particular kind of ASIC. There are channels that will open in response to intense mechanical energy, not the kind that occurs with fine touch or stroking the skin. We're talking about hammers, pinches with pliers and stuff like that. And finally, there are nociceptors that respond not to elevated temperature, but much reduced temperature, less than 15 degrees centigrade. And they do so because they have another member of the TRP family called TRPM8. TRPM8 channels open when the temperature around them is below 15 degrees centigrade. They're in a separate kind of nociceptor and reports then cold pain. You grab a hold, put your hand in a bucket of ice and see how long you can keep it there. It is not fun at all. So that's what we've got, is it's painful. You feel pain when your hand's in the bucket for a while because TRPM8's open and they're in a specific kind of thermal nociceptor. Bottom line here, different kinds of protein complexes forming receptors in the membranes of nociceptors respond to different qualities. And those qualities all wind up being painful to us because all of these protein complexes are present in the plasma membrane of different types of nociceptors.